So now we see the problems belongs to stoichiometry. Okay, see the first one. When 100 milliliter of 0.06 m molarity is given, ferric nitrate and 50 milliliter of 0.2 m ferric chloride and 100 milliliter of 0.26 m magnesium nitrate. The three solutions are mixed. We need to find the concentration of all individual ions in the final solution. Here three solutions are given. Three solutions mixed. So what are the concentration of individual ions in the final solution? Find out shall. So what are the three solutions? See the first solution, 100 milliliter of 0.06 m ferric nitrate. So it releases which ions? So Fe, NO3, take it 3. So the ions released from it is Fe plus 3 and 3 nitrate ions. So what are these concentrations? 100 milliliter 0.06 m. So what is Fe plus 3 now? Fe plus 3 we calculate in terms of millimoles. Okay, the milliliters are given. That's why we calculate in millimoles. So molarity is given, volume is given. So that's why we are calculating in millimoles, in terms of millimoles. So molarity, only one Fe plus 3 is there. That's why just we are taking only one only. That gives 6 millimoles. 6 millimoles of Fe plus 3, first solution. Next, what are the nitrate ions? What are the nitrate ions? Here their concentration 0.06 of the same solution. Having 3 moles of such type of ions are released. 3. Same, the volume is 100. So here we get 18 millimoles of nitrate in the first solution. Okay, let's see the second solution. So this is about first solution. Now see what is in the second solution position. So second solution, ferric chloride. Ferric chloride means FeCl3. So it gives Fe plus 3 and there is a formation of 3 Cl minus, 3 chloride ions are there. So Fe plus 3 only 1 mole, chloride is 3 moles. The total, now we see the Fe plus 3 concentration in second solution in terms of millimoles. Millimoles, why you are using millimoles means the concentration given in molarity, value is given in milliliters. That's why we are able to calculate millimoles only. So now what is the Fe plus 3 concentration? Only 1 mole, that is 0.2 into that is 50 milliliters. Okay, only 1 mole of ion is there. So that is equal to 10 millimoles of Fe plus 3 here in the second solution. Next, in the second solution, chloride are there. The chloride ions, same 0.2. But how many such type of ions are there? 3 moles. Okay, so that is equal to 30 millimoles. 30 millimoles of chloride ions are present in the second solution. Next is the third solution, 100 milliliter of 0.26 m magnesium nitrate. So see the third solution, magnesium nitrate gives which ions? Mg plus 2 magnesium ion and 2 nitrate ions. Okay, here 1 mole of Mg plus 2 and 2 moles of NO3 minus. So what is millimoles? Again it's molarity into volume in milliliters. Therefore Mg plus 2 is in the solution 0.26 into 100 ml, that is 26 millimoles of Mg plus 2. Next, what about NO3 minus? Same 0.26 100 milliliter, but such type of ions 2 are present. That is 52 millimoles. So these are the conditions, nothing but these are the composition of 3 solutions in the mixture. The values are different, but in the mixture if you see their millimoles, Fe plus 3 6 millimoles, and here again Fe plus 3 in the second solution 10 millimoles. So what is the total millimoles of Fe plus 3? 10 plus 6, 16 millimoles. See the Fe plus 3, the millimoles. So we need to find the concentration means. Concentration means generally we can use moles per liter. Concentration manam moles per liter usage. See, for concentration there is 2 possibilities. We can calculate number of moles per liter if it is given in number of moles. But here we got everything in terms of millimoles. So or the concentration we can write in terms of millimoles by volume in milliliter. So now we will follow this formula. For concentration of each ion we will calculate with the help of this formula. That is millimoles by volume in milliliter. Here value means we need to calculate in final solution. So what is the value of final solution? Volume of final solution, here it is given 100 milliliter, here 50 milliliter, so 150, here 100, total 250 milliliter. Means we need to calculate the concentration of these all ions separately in this final solution. Okay, final solution lo concentration మనం find out చేయాలి. Okay, now we see the concentration of Fe plus 3 is equals. So what is the total millimoles of Fe plus 3? 6 millimoles, and here 10 millimoles. Total 16 millimoles in 250 milliliters. This value is approximately 0.064 concentration in terms of molarity. Next is the concentration of nitrate ion. What are the total millimoles of nitrate? What are the total millimoles of nitrate in the final solution? So in the first solution there is 18 millimoles of nitrate, 18, and here again it is 52. Okay, the total there is 70 millimoles, here 52 millimoles, here 18 millimoles. Total 70 millimoles of nitrate is present, same present in 250 milliliter. And here the approximately the value we can calculate 0.28. Next remaining we need to calculate 2 ions, that is Cl minus. So what is the total millimoles of Cl minus in first solution? There is no Cl minus. In second solution there is 30 millimoles of solution chloride. In third solution also there is no millimoles of Cl minus. So there is total millimoles of Cl minus 30 by total volume 250. So it approximately gives 0.12 molarity. Okay. Next remaining one, only magnesium ion. What are the magnesium ion millimoles? This is 26 by total volume 250. So finally you got 0.104 moles. So these are the concentrations. So these are the concentration of all individual ions: ferric ion, nitrate ion, chloride ion and magnesium ion in the final solution. Just listen briefly again. Here three solutions are given and said that all solutions are mixed. We need to find what is the concentration of all ions in the final solution. So if final three solution mix cheste different solutions. కొన్ని ions similar ఉన్నాయి, కొన్ని ions different ఉన్నాయి. సో ఈ సొల్యూషన్ మిక్స్ చేసినప్పుడు ఆ వచ్చిన ఫైనల్ సొల్యూషన్ వాల్యూమ్, సో ఇది 100, దిస్ ఈజ్ 100, దిస్ ఈజ్ 50, 250. ఆ 250 ml సొల్యూషన్లో ఇండివిజువల్ ఐరన్ కాన్సన్ట్రేషన్ ఫైండ్ అవుట్ చేయాలి. ఇది టోటల్ సింపుల్ వన్. సో ఫెర్రిక్ నైట్రేట్ అంటే మనకి ఏ కాంపౌండ్ ఏ ఐరన్స్ రిలీజ్ చేస్తుందో వీ నీడ్ టు నో దట్ ఓన్లీ. ఫెర్రిక్ NO3 minus. We are converting them into millimoles. Millimoles means molarity into volume in milliliters. Molarity is given, volume in milliliters given. That's why the total problem we are doing in terms of millimoles. We are calculating millimoles of all individual ions in the three solutions. And we need to give the answer final is in final solution. So we need to add the similar ions millimoles. For example, ferric. In first solution ferric is 6 millimoles. In second solution ferric is 10 millimoles. Totally 16 millimoles by total solution. Same nitrate. Nitrate only in first solution 18. In the third solution there is 52 millimoles. So that's why there is totally 70 millimoles by total. So remaining chlorine present in only in one solution. And magnesium plus 2 also present in only one solution. Okay, got it. Okay, see the next one. 250 milliliter of this is total different from earlier ones. 250 milliliter of X molarity solution. When there is a solution is there with X molarity, and 50 milliliter of another solution with 5 molarities, 5 Y molarity of a solute are mixed. Means the solute present in both solutions is equal. This what is the difference means? The first solution is 250 milliliter with the first solution is 250 milliliter with X molarity. The second solution is 500 milliliter with Y molarity. Both are mixed. Then again they are diluted to 2 liters. Means what is the final volume here is 2 liters. Generally by mixing these two 500 we will get here 250 only 750 milliliter, but here we get it is diluted to 2 liters, and already there is a 750 is there. By adding again 1250 milliliter of water it came to 2 liter to produce a final concentration of 1.6 m. 2 liters water కలిపి ఈ రెండు సొల్యూషన్స్ కలిపి 1250 ml water కలిపితే the final solution concentration become 1.6 molarity. So we need to find X and Y. What is the concentration of first solution? What is the concentration of that second solution? The clue is given that the ratio of this x and y is 5 by 4, not even 5 is to 4. We need to calculate x and y. So first we see the 250 milliliter of x, 500 milliliter of y of same solute. Mean they may be acid, they may be base, or they both may be acids or base or salts, but both are equal. That's why if same solutions are mixed, if two solutions are mixed, so we can write the formula m1 v1 plus m2 v2 is equal to m3 v3. Okay, now we substitute them. So what is m1? What is the first concentration? X. What is the v1? Plus what is the m2? Y into 500. And the solution diluted to 2 liters. These two are in milliliters. Therefore, we are writing in milliliters. What is the final concentration? 1.6 into, that is 2 liters means 2000 milliliters. So we need to get one equation, one relation here, that is by dividing this total equation. So first we are writing the total equation in normal way. (250x 500y is equal 1.6 into 2000). Okay. So now divide all them with 250. Okay, 250 to divide with them. Dividing with 250 to this equation. Here we get 250 by 250 means x plus this is 2y. This is equal to 1.6 into by 250 means it becomes 8. This approximately gives 12.8 something. Say it is equation 1. And next it is given that, so what is the given relation? X is to 5 is equal to 5 is to 4. Nothing but we can write x by y is equals 5 by 4. Or we can write x equals 5y by 4. Okay, say it is equation 2. Now substitute the 2 in equation 1. Substitute the 2 in equation 1. Okay, then we get in the place of x we can write 5y by 4. 4 plus 2y equal 12.8. So now this multiply this with 4. Multiply this equation with 4. Multiply this equation with 4, we will get here 4 get cancelled. Say it is equation 3. Now the 3 implies 5y plus multiplying with 4, 8y is equal to 12.8 again into 4. It becomes approximately 50. 0.2. So therefore 13y is equal to, and y is equal to 13. Generally approximately it is 4. 13 for the 52. So it is somewhat less. So that is approximately near to 4, that is 3.94. So molarity of y is molarity of the second solution given as y. So now it is calculated as 3.94 m. So with the help of in second equation, substitute the y value in second equation, we get the x1. That is a 5y. 5 into its y value obtained as 3.94, approximately we can say 4 by 4. 5y by 4. So finally we got approximately 5 means 4.9. Okay. So these are the concentrations of two different solutions. Two different solutions mixed with different concentrations and diluted with some water, and finally made that solution to 2 liters, and final concentration is obtained as 1.6. We need to find out the individual concentration of the two solutions, and there is also given clue x is to y equal 5:4. So we know that by mixing two solutions of similar character, we use the formula m1v1 plus m2v2 equal m3v3. Okay, by substituting these values we get this equation, okay, in terms of x and y, and with the given information x is to y equal 5/4, that is the second equation in terms of x and y. So now we are substituting the second one in equation 1. So here we got the y value, and the y value here is substituted in equation 2, getting the x value. So finally the first solution concentration is 4.93 molarity. Second solution molarity y is equals 3.94 molarity. Okay, got it. See the next one. Next one. So which is also similar to the earlier one, but here the information given is somewhat different. So we need to find what is the normality of a solution that results by mixing 7.4 grams of calcium hydroxide, 500 milliliter of 1m HNO3. It is given in terms of weight. Okay, 7.4 grams of calcium hydroxide, 500 milliliter of 1m HNO3. Its concentration is given, value is also given. Next, the third solution is 10 milliliter of H2SO4 of 48% with specific gravity 1.2, and the total solution again, just like earlier problem, the total solution was mixed to 2 liters. Here the total solution after mixing, the solution is changed to nothing but diluted to 1 liter. This normal by mixing here, this is 500, this is 10 milliliters. We know the exact value of this, but the total value is made to 1 liter. We need to find out the normality of 1 liter solution. Here normality find out share of final solution. So normality kabatti, so compulsory we need to take the concentration in terms of milli equivalents. So concentration ante inta mundu problem lo, in first problem we done in terms of millimoles, because at that time molarity is given, value is given in terms of milliliters. So akkada molarity icharu, molarity given and volume given in terms of milliliter. So direct the millimoles calculation. Here also we can calculate direct millimoles only, but at finally we need to get the normality. So final గా normality అవసరం కాబట్టి మనం స్టార్టింగ్ నుంచి మిల్లీ ఈక్వలెంట్స్ క్యాలిక్యులేటర్ తీసుకోవాలి. See the first solution. So what is the first solution? 7.4 grams of calcium hydroxide. So what are the milli equivalents? Milli equivalents means we know that. What are milli equivalents? Milli equivalents are always equal to N1 V1. But here only we are calculating for this purpose only, N into V. So what is this? Normality is not given. Normality means we know what is the formula for normality? Weight by equivalent weight. Equivalent weight means weight by equivalent weight. Equivalent weight means molecular weight by it's a base. We need to write acidity. Acidity into 1000 by value in milliliters into value. The two value terms will be cancelled. Here we get 7.4. So what is the molecular weight of calcium hydroxide? Calcium hydroxide will give calcium 40, 2 oxygens 32 and 2 hydrogens. Finally we get 74. So the final millimoles is equal to milli equivalents will directly we will get 7.4. That implies so we will get finally 100. See 7.4 weight as a molecular weight by acidity. So we need to write the acidity also. Okay, by acidity. So here the acidity of this is 2, that is 2. Totally we get 200 milli equivalents. If we calculate the molarity, we will get the millimoles, but here we calculated the normality, so that's the milli equivalents. So this is about first solution. First solution, that is calcium hydroxide is a base, so it is a base. 200 milli equivalents of a base is present here. So see about the second solution. The second solution is 500 milliliter 1m HNO3. So it is acidic solution. So what are the milli equivalent of that acids? Normality into its value. So what is the normality? 1 molarity is given. What is the N factor for HNO3? 1. That is 500 value. That is 500 milli equivalents of HNO3. And that is for acid. Let's see the third solution. So for the third solution, it is given 10 milliliter of H2SO4 and 49% of solution having specific gravity like this. Means we know the value, but we don't know the normality. So we find the normality of the solution. The normality of third solution is, we do the formula in terms of given percentage. If percentage given, we know the formula of normality is percentage into 10 into specific gravity by gram equivalent weight. We are calculating normality, that's why we are taking gram equivalent weight. If molarity, we can use gram molecular weight. So normal. What is the percentage given? If what percentage is exactly given, the 10 into specific gravity is 1.2. So the value specific gravity, density, such type of values must be given in the problem, except for water. Gram equivalent weight means it's acid by its basicity. So here we got normality 12. This normality for, this is normality of acid. So normality means what are the milli equivalents? Now milli equivalents means normality into what is its volume? 10 milliliters. That is 120 milli equivalents of H2SO4 acid. అంటే ఇక్కడ given three solutions are, one is base, remaining two are acids. Means here all are not similar character. The first solution is basic one, whereas other two solutions are acidic one. So there may be acidic character somewhat dominates when compared to the basic. But how much acidic we need to get it. So we'll compare therefore the first solution so from these three solutions we get milli equivalents of the given base is how much? Just 200. And the milli equivalent of total acids, here two are acids, HNO3 and H2SO4 both are acids. So 500, that is this is 500 milli equivalents of acid, this is 120. So it's become a 620 milli equivalents of acid. So milli equivalents exactly cancel. Means the 200 milli equivalents are exactly compensated with the 200 milli equivalents of acid. So what are the milli equivalents of acid left in the solution? 620 milli equivalents of acid reacts only 200 of that base. So finally we get 420 milli equivalents of acid. అంటే ఫైనల్గా టోటల్ రియాక్ట్ అయిన తర్వాత సో రిమైనింగ్ పార్ట్, సో ఫైనల్గా మిగిలిపోయిన పార్ట్ దట్ ఈస్ 420 మిల్లీ ఈక్వలెంట్ ఆఫ్ యాసిడ్ మిగిలింది ఆఫ్టర్ కంపెన్సేటింగ్ 200 మిల్లీ ఈక్వలెంట్ ఆఫ్ బేస్. నౌ వాట్ ఈస్ ద normality? So we got milli equivalents. Again we need to convert it into normality. So what is the total volume of the solution? Total volume is made to 1 liter. So here normality and volume is given as 420. We need to find normality. That is 420 by, what is the volume? 1000. Okay. So approximately we get 0.42 normality. Okay. So these are the three solutions are mixed. In this problem, the information about the three solutions are given in different way. The first solution given weight. We convert that weight into normality and into milli equivalents. For the second solution it is given exactly the milliliters and the electric molarity is given, we convert them into milli equivalents. అదే థర్డ్లో మనకి ద పర్సంటేజ్ స్పెసిఫిక్ గ్రావిటీ ఇచ్చిండు, మనం దాన్ని బేస్ చేసుకుని నార్మాలిటీ మళ్ళీ మిల్లీ ఈక్వలెన్స్ క్యాలిక్యులేట్ చేసినాం. సో ఇచ్చిన 3 సొల్యూషన్స్లో 2 యాసిడ్స్ ఉన్నాయి, 1 బేస్ ఉంది. సో బేస్ మిల్లీ ఈక్వలెన్స్ వి గాట్ 200. అదే యాసిడ్ మిల్లీ ఈక్వలెన్స్ ఎంత వచ్చాయి 620. HNO3 500, H2SO4కి 120. సో మొత్తం ఇక్కడ 620 వచ్చినాయి. అయితే ఒక కంప్లీట్ రియాక్షన్ అయినప్పుడు యాసిడ్ మిల్లీ ఈక్వలెన్స్ బేస్ మిల్లీ ఈక్వలెన్స్ ఈక్వల్గా కంపెన్సేట్ అవుతాయి. దీంట్లో 200 బేస్ ఉంది కాబట్టి యాసిడ్లో ఉన్న 200 మాత్రమే రియాక్ట్ అవుతుంది. సో రిమైనింగ్ లెఫ్ట్ ఎంత, we got 620 minus 200, the 420 milli equivalents of acid will be left. ఇప్పుడు ఆ ఫైనల్ సొల్యూషన్స్లో ఏముందంటే, ఆ ఫైనల్ సొల్యూషన్లో 420 మిల్లీ ఈక్వలెంట్ ఆఫ్ యాసిడ్ ఉంది. దాని వాల్యూ ఇట్ మేడ్ ఇట్ టు 1 లీటర్. ఇప్పుడు ఆ 1 లీటర్లో 420 మిల్లీ ఈక్వలెంట్ ఆఫ్ యాసిడ్ ఉంది, మిగతా బేస్ యాసిడ్తో రియాక్ట్ అయిపోయింది. సో ఆ రిమైనింగ్ యాసిడ్ మనం నార్మాలిటీ ఫైండ్ అవుట్ చేయాలి. సో మిల్లీ ఈక్వలెన్స్ అంటే నార్మాలిటీ ఇంటూ వాల్యూమ్ ఇన్ మిల్లీ లీటర్, or you got the value as 420. So normality equals 420, its value is given 1 liter. So finally you got 0.42 normality. Okay. So take the similar problem, just calculate in your notes. Okay.